Note that where current is defined as the number of charges passing a point in a given time, positive current flow should be considered with the understanding that the flow of electrons opposes conventional current due to their having a negative charge. Here I'll explain the significance of semiconductors concerning current direction and application. By name, semiconductors fall between conductive and insulative material. Silicon, an abundant semiconductor of group 4 in the periodic table with 4 outer shell electrons, can bond with itself to form a crystalline structure leaving very few holes or free electrons. To alter the conductivity, regions of silicon are doped with either group 3 acceptor elements to give a hole per acceptor for a positive charge, or group 5 donor elements to give a free electron per donor for a negative charge. Free electrons are passed between atoms through materials as a source drives more free electrons through it. Holes are spaces where incomplete bonds between different atoms can accommodate the passing of electrons. As shown, the movement occurs many times very quickly, but more like this with this. Diodes consist of an N and a P junction of opposing polarity that have established between themselves by way of a process called diffusion, an equilibrium called the depletion layer, a potential barrier, a field by which extra electrical energy is required to traverse. This barrier can be overcome to produce current flow in one direction. If connected in reverse bias with the N junction connected to the positive terminal, electrons are attracted to the positive source terminal and vice versa, increasing the width of the depletion layer and giving for a high potential barrier restricting current flow through the semiconductor. If connected in forward bias with the polarity of the source reversed, the augmentation in both directions of charge carriers and counteracting holes decreases the width of the barrier, allowing current to flow. This field effect gave way to the birth of the modern transistor, essentially two diodes stuck together 91 years ago. The fundamental, ubiquitous, mysterious creation by which we are outnumbered tens of millions of times.